Today's video is about building this, which is a nice little portable GFCI receptacle for testing purposes. And to make it really ideal for testing purposes, what I've done is I've used a nice short plug of the 15 amp variety with a GFCI of the 20 amp variety, so I can easily plug any device under test into this, even though the plug itself is not really rated for 20 amps. But the other really unique thing is to add a isolated ground receptacle to the output of the GFCI, and in this case the isolated ground is so isolated it's not connected. And the reason I've done that is there are some cases where if you're testing a device you may actually wish to not have the ground connected, because for safety purposes you may be really trying to minimize the chances of two parts of your body touching something and touching something else that might be live, and that could be, in some very specific situations, the grounded chassis of a device under test. Now, I'm going to have a separate video about testing and safety and all sorts of things of that nature, so I'll just leave it at that for now. The bottom line is when you're doing any sort of testing to repair a device or to work on a prototype, you really have to think about the implications of how to connect it safely and whether or not a groundless or grounded connector is appropriate. Now, the thing you may not realize is that in many places a GFCI connector is considered an acceptable alternative if you need to plug in a grounded device into a installation that has no ground, because the plug in the house is so old, and what you're allowed to do is put in a GFCI plug and leave it ungrounded. So there are plenty of precedents of using GFCIs without the ground attached at all. In this case, we're just going to make sure that we have a choice between a grounded or ungrounded GFCI connection. So with that said, let's go ahead and build this nice device. I want to put this in here and this in here like that, right next to each other. But all I have is this type of box cover. And unfortunately, what I really need is a box cover with a rectangular hole for a what's known as Decora type outlet in it. And I looked at the big box stores and they don't have any in stock. And I looked at Amazon, and the cheapest one of these that I could find was about 14 bucks, with some people selling them as much as 60. You really got to wonder about ads like that. I mean, there must be some takers, but I'd hate like hell to encourage someone selling these things at 60 bucks, and even 14 bucks is somewhat of a ripoff, because they should really cost about 4 bucks or so. So what I'm going to try and do is cut this into a rectangle and see if we can use what we have. And to do it, I have this rectangular Decora faceplate, and it will become the template. And the trick is going to be to try, maybe I'll just get this box away so it's more stable. The trick is going to be to try and use this template by marking it, and I want it to be as even as possible in both directions, in all directions. That looks pretty close. So these are the parts that I'm marking here. that I'm going to cut away. So when I'm done cutting with a Dremel, everything that's black should be gone. And if I've done it right, the Decora outlet will fit perfectly through there. So having said that, let's try it. All done, and it looks reasonably good. Now it's actually almost too hot to touch from all that energy, all that frictional energy, but let's see if it fits. Well, gonna have to clean it up just a little bit, and I think what I'm going to do is, while it's cooling off, I'm going to change the grinding tool at the end of the Dremel to make it easier to smooth these things off a bit. Okay, so I've changed the grinding tool at the end of the Dremel. This should be a little bit easier for flattening these things out. And I think the thing to do is to put this over here, and we can just sort of mark a little bit where we might need to correct things just a bit. We'll try those little areas first, and then if need be, do a little bit more. All right, let's see how that works now. Does it fit at all? Put it actually this way. It does fit. The reason it didn't go in from the other side is these end tabs are too long, so we will take them off now. And to take them off, I'm gonna, well, we'll first take off these side tabs. And then we'll hold the main tab, and you may or may not be able to see it, but there is a little bit of an indent here, so you can actually break that off if need be. And need does be in this case. That came off nicely. Now we'll do this other one. Okay, so now the question is, does it fit? Yes, it does. It may not be the most beautiful outlet, but it certainly fits. And the only other thing we really have to do now is put a couple of holes in here so that we can attach the outlet to the faceplate with a screw. So those are nicely marked. So to make drilling a bit easier, what I'm going to do is make a little indent here. And one hopefully in the same place down here. Okay, so to drill it, what I'll do is just put it on top of this piece of old wood so I can drill right into it without messing up the workbench, well, or messing up the workbench any more than it already is. That should do it. Now the other side, same thing. And then the only other thing to test is make sure the holes are big enough for the screws. Looks like they are, just barely. You know, what we'll do is we'll just widen them just a little bit. Yeah, that should do it. So let's try it. So we want this to go in here like this. We will put one screw through. Believe it or not, it fits. So now, the other screw. That's in nicely. And now what we got to do is put this other socket in here like this. And to do that, we will use the screw that was in the part that we dremeled out. And I got to give it a push because these screws have a little unthreaded area right next to the head so that it can stay in the metal but not fall out. So you see right now it's almost as if I'm putting it through a threaded hole, not quite, but once it's in, there we go. See, it won't come out at all now. So we'll just put that on here. And there we go. That is now ready to add the power cord and to connect these two things together. So what we have to do now is take our newly built faceplate and attach a bunch of cables to it, and also string a cable, this nice thick one that came from a failed heater, in through here. And I guess we have to make sure that it'll fit, and it should fit if we make sure that this bigger GFCI outlet is away from the hole, because what we're going to have to do is put this connector or clamp in the hole, and that will eat up a little bit of space within the box. So let's do that right now. And we'll get that reasonably tight. This is sort of getting stuck for some reason. Yes, this is not a proper hammer, but it's good enough. Okay, that is now nice and solidly attached. So the next thing to do is we need to strip some of the wiring off or some of the cladding off the cable, and we need to have enough wire coming out so we can reach around and attach to this socket over here. So we really need about this much wire. So being very careful, we will try and put a fine slit that's not too deep in the cladding, and if we're lucky, it'll sort of split the cladding without damaging any of the internal wire. Yep. And now we'll just carefully cut around here to get the rest of the cladding off without damaging any of the cables. Like that. So now this should fit nicely in here. And there certainly is enough cable that we can attach to our socket. So the only thing that remains to be done with this cable is we need to strip it to a reasonable length. That was sort of a mess. And the one that worked. Okay. And I think I actually need a little bit more for the ground. There. Now, for the ground, normally in a box like this, in a newer box, the threaded holes for the ground screw are actually raised up. The problem we're going to have here is the threaded hole for the ground screw on this older box is in fact level with the outside of the box, and this will be sticking out, and since we're just going to be having this box flop around, that's probably not a very good idea. And the question would be, are we happy enough just using the ground on the GFCI connector, which in turn attaches to the faceplate, which in turn attaches to the rest of the box, or do we think it's necessary that we put in a separate screw, maybe through the bottom of the hole like this, through the bottom of the box like this, and put a nut on top of here and attach a ground wire to that, and that's probably going to be the preferable way of doing it. So with that in mind, I'm going to stop recording and find an appropriate nut. After a bit of searching, I think I found everything that we need, and that includes this screw here, which is just the right size to go through our grounding hole, and the end of the screw is nicely rounded so that it's not going to really snag on anything too much. And then on top of the screw I have a couple of washers, a smaller one well, I guess we'll just use the bigger one. And that washer will go here with the nut over it. And so what we can do is now put a ground wire around the screw and use it to nicely ground the GFCI plug to the case. And if we just look, it's like this, so the ground is going to be here. So what I'm going to do is make sure we have plenty of ground wire coming around to that part of the box. And I'll just flip this over to get the washer in place. We'll put our ground wire, we'll make it a little bit longer, because what I want to do is be able to get this maybe over here out of the way of the big plug. So we'll make it just a little bit longer on this side. Yeah, that should maybe do it. Okay. It is really annoying to try and get the wire under that washer. Now it's under the washer, and we can tighten it up. And yes, pliers is not the perfect way of doing it, but I happen to have them within reach, and so that's what we're going to use. Okay, that's good and tight. We're nicely grounded to the box. We can now put our cable in, and we'll take this opportunity to tighten it. So it's nice and secure. That's good. So that's secure. So now we need to wire these things together. Just get the price tags off them. And the reason I'm taking the price tags off is so we can see the notes on the bottom of the switch, bottom of the receptacle. And if we look very carefully, it says over here, line, pointing to these two contacts, and it'll say load sort of under that mess here, pointing to these two contacts. And what that means is we need to take our line, our incoming power, and attach it to here, and then we'll use another set of wires to connect this over to this plug, because this plug is our load. So we'll just take the orange plug off. yeah, now we can access everything here that we need to access. Maybe we'll do the neutral first. And in North America, the color code is brass for live and shiny silvery for neutral. And that, of course, corresponds to the white wire here. Is it long enough? Yep. So we'll put the neutral in there. These are really nice terminals for attaching to stranded cable, which is, of course, not the usual one that's used for house wiring and outlets like this. And then over here, I think we need to make this just a little bit longer. We'll now attach our live wire, black being the North American standard for a live. Again, yeah, that's nice and long. So it can go in here, and we'll tighten that one up. Good. And now the ground, and we'll just use the pliers to make a nice little, oh, this one, no, this ground does not need a bend. This is a really nice outlet. It has a piece of metal that you can just stick the ground under, and that should, yeah, we want that in nice and tight. I'm just holding it there and trying to do it so you can see this at the same time. So that's a good tight ground, and there is enough cable so that we can, how are we going to mount it? We're actually going to mount it like this. We're going to mount it like this because we need the space over here for these tabs in the box. So there is still plenty of space to have it fit in like that, so that's perfect. Now what we do need to do is attach the incoming ground to the little ground wire we added, and we'll just put that right around here like that, and then put our MAR connector on it, and turn it nice and tight, and that'll be a pretty good ground. And now what we need is a couple of short wires to attach the load from our GFCI connector to the terminals of our isolated ground receptacle. And one thing I am going to do is install it so that the grounds are actually facing the other direction. And the reason is because this is going to be a groundless connector. I want to make it a very conscious decision when one is connecting something into here or here. And if you're sort of doing it and not paying attention, you don't want to accidentally pull something out there to stop some device under test and then accidentally plug it in over here. So that's how we're going to mount them. What that sort of means is we're going to have our two lives next to each other in the box, and our two neutrals opposite. So we need a longer white wire and a shorter black wire to connect these things together. So I'm going to go quickly find some wires to do that. Okay, I just stripped and cut to length a couple of short little hookup wires, and we will use them. And one thing I did discover was the length of wire for the two sockets is slightly different. So I did strip them appropriately. So that's going to be our neutral, and this one, because of the brass colored connection, is going to be our live. There we go, nice and tight. And now all we have to do is attach these two things to our other two sockets, and we'll maybe just bend this so it goes in nicely. It's actually so long we'll put it in the screw that is furthest away. Like that. It's actually still just a little bit too long. I'm going to shorten it just a bit. And again, we'll put it in the more distant screw here and tighten it up nicely. And now we will attach our neutrals to the shiny terminals. And because we don't want the ground attached, and I will talk about that in a minute, what we'll do is leave the ground, well, unattached. And maybe we should just look at this real quick. Unlike a more conventional outlet, this outlet actually has insulation between the ground screw going to the grounding pins and the attachment to the box, which is all normally grounded together. And it's because this thing is supposed to be an isolated ground and isolated from all the metal on the box and any conduit normally going back to the circuit breaker panel. And this is typically used for hospitals where they want to have separate grounds for added safety, and also for some high-end places like recording studios where you're trying to do everything you possibly can to minimize things like stray ground currents and noise. And I think maybe its use for that sort of application is perhaps a bit dubious, but that's what people do. So there we go. It is all tightened up together. What we'll do now is basically bend these wires so they're, we'll bend these wires so they're nice and flat and really out of the way, because there isn't much space in this box. And again, it's going to go something like that. Does it all fit? Yes, it does. Quite nicely, in fact. Or did I speak too soon? And now what I need to do is try and put these screws in. There actually, isn't quite enough space here for that. So can I get it in at all? Yeah, I guess it'll just barely fit, but boy, is that ever tight. Yeah, that's in, but it's tight. And there we have it. So that is our portable GFCI box, and we should, this is what happens when you tighten those things too much. The outside bends. That's a bit better. Yeah, that's a bit better. So let's try it. And to try it off camera, I'm going to plug it in. You can trust me on that. And we will plug in our nifty little ground detector. And right now the GFCI is actually triggered, so I'm just going to reset it. And is this visible in the camera? Yes, those two lights are on and the red is off, meaning this is a connection as you would expect. We can press the tester on the GFCI and it disconnects everything. And now, if we plug our tester in the isolated ground, you can see that only the center light is glowing, meaning on a normal socket, this thing would be saying, hey, there is a bad connection on the ground, and indeed there is, because we've purposely left the ground disconnected. Now I'm going to do one more thing, and that is I have these two child-proof socket protectors, and I'm going to put them in here. And what the idea is to put these into whichever socket I've deemed to be the one that I don't want to use for whatever tests I'm performing. And that way I can't accidentally, without thinking, plug the device into the wrong socket. That brings this project to an end. I am going to do a follow-up video to discuss using this device as well as isolation transformers and other things for electrical safety when repairing, prototyping, or even testing devices during the manufacturing process. See you then.